When we watch an early industrial machine slamming into place, we are looking at raw physical power executing a repetitive task. Technology has a long history of replacing human labor, but the way it selects its targets is rarely neutral. During the 19th century Industrial Revolution, the introduction of the factory system and interchangeable parts was deliberately designed with an unskilled bias. The goal was to remove highly educated workers from the production equation entirely. Before these factories existed, manufacturing relied heavily on solitary artisans. These craftsmen spent years mastering complex manual techniques in highly specialized workshops, giving them significant leverage over their wages. Factory owners recognized they could drastically reduce production costs by designing systems that specifically bypassed that expertise. They replaced the educated artisan with cheap, uneducated laborers operating vastly simplified machinery. That dynamic reversed in the 20th century. With the adoption of electricity and complex batch production methods, operating new machinery suddenly required specialized knowledge, launching what labor economists refer to as the human capital century. By the 1970s and 80s, the assimilation of microprocessors and complex computer terminals forced workers to adapt to highly intricate interfaces. This era defined the core concept of skill-biased technological change. It is the economic principle where a new technology increases the relative productivity of highly educated workers, driving up the demand for their labor and the premium on their wages. Economist Jan Tinbergen conceptualized this market dynamic as a constant race between education and technology. As long as the educational supply of the workforce keeps pace with the complexity of new tools, wage inequality remains stable. We are now experiencing an extreme acceleration of that race. Artificial intelligence agents are driving a highly specific evolution of skill-biased change. They are targeting and hollowing out middle-class roles, shifting economic value entirely toward non-routine abstract thought. To capture the resulting wage premium and survive the transition, a modern knowledge worker must understand the specific technical architecture driving these AI systems. The primary target of modern AI automation is the traditional mid-level knowledge worker. To explain exactly which jobs are vulnerable, economists refined the skill-biased model into task-biased technological change. This framework clarifies that AI software does not uniformly substitute for human beings. It substitutes for specific, predictable procedures. This animated matrix breaks the modern labor market down across two distinct axes. Tasks range from cognitive to manual on the y-axis, and from routine to non-routine on the x-axis. The upper left quadrant is routine cognitive. This encompasses roles built around precise, well-understood procedures, clerical work, sorting, and heavily documented middle management tasks. Because software excels at strict logic, AI directly substitutes for these precise procedures. The demand for human operators in this quadrant is shrinking. Contrast that with the non-routine abstract quadrant on the right. This covers complex problem-solving, creative strategy, and medical diagnosis. Technology acts as a productivity multiplier here. Generative AI exhibits strong complementarities with these tasks, amplifying the output of highly educated professionals. Meanwhile, non-routine manual tasks at the bottom, like food preparation or personal care, require physical, situational adaptability that machines cannot yet easily replicate, leaving them largely insulated. This specific pattern of automation results in job polarization, hollowing out the middle class, isolating employment growth at the high-wage top for professionals and the low-wage bottom for service workers. Surviving this shift requires adaptation. A worker must actively strip their daily tasks out of that shrinking routine middle and migrate into the abstract top. To understand how AI can dominate routine cognitive tasks, we have to look past simple chatbots and examine the technical shift to autonomous agents. While a standard chatbot simply sits idle waiting for your prompts, an agent operates in a self-directed loop. It formulates a plan, takes action, observes the result, adjusts, and repeats until the goal is achieved. This animated schematic details the 4 specific components required to build a functional, autonomous AI agent. At the core is the model. This is the underlying intelligence, dictating reasoning capabilities and its general knowledge base. Encircling the model is the harness, This layer provides strict instructions and hard-coded guardrails. Branching out from the center are the tools, external software and APIs the agent is authorized to manipulate. Finally, everything sits inside the environment. This represents the broader context, the corporate network or the file system where the agent lives. If you assign an agent to file a business expense, it uses a tool to transcribe a physical receipt. It then checks the harness layer to ensure the amount complies with company limits. If a hotel charge exceeds the nightly cap, the system hits an error. Instead of pausing to ask a human what to do, the agent autonomously queries its environment, searching a shared drive to learn the exception policy, then adjusts its plan and submits the correct code. Through the integration of these 4 layers, an AI agent can independently execute multi-step workflows that used to consume a human worker's entire day. This autonomy introduces a severe paradox. The exact access to tools and environments that makes an agent useful simultaneously opens new vectors for systemic vulnerability. A prime example is the prompt injection cyber attack. This occurs when malicious instructions are secretly embedded inside the routine text or emails an agent is asked to process. This animated diagram maps how an external attacker targets the agent's autonomous workflow to bypass human oversight. The hidden prompt overrides the protective harness, tracks the central model's reasoning, and exploits an outward tool to silently forward private corporate data directly to an attacker. Because prompt injections can exploit any combination of those 4 architecture layers, no single line of defense is sufficient. Raw, unsupervised execution by an agent is too dangerous for a secure enterprise. This security reality dictates a shift in human labor. Workers must stop actively doing the routine tasks and pivot to governing the systems that do the tasks. This interface demonstrates plan mode. This design allows the agent to present its entire intended strategy up front, rather than asking for permission at every microaction. This design choice forces the human operator to elevate their level of oversight. The worker's job is no longer to execute the steps, but to review the overarching strategic intent and authorize the workflow. Managing multiple sub-agents executing different parts of a project in parallel requires high-level ethical judgment and complex problem-solving to ensure the system remains aligned. Providing that secure governance is a non-routine abstract function. Navigating ambiguity and aligning complex AI actions is exactly what modern employers are paying the wage premium for. When we merge this technical reality with economic theory, the blueprint for the modern knowledge worker becomes clear. Let's look back at the task matrix. The 4-layered agent architecture maps onto the routine cognitive quadrant. Software has occupied this space. The knowledge worker must structurally abandon routine batch work. You have to migrate your daily efforts into the non-routine abstract quadrant. Unlike repetitive clerical work of the past, abstract functions like ethical judgment and complex problem-solving require a much higher degree of cognitive intensity. Research into focus-based productivity shows that high-quality human output for these specific tasks drops off sharply after 3 to 4 hours of deep concentration. Beyond that window, ideas come less easily and decision-making falters. This biological constraint is why the modern worker is increasingly adopting the 4-hour rule, treating focus as a scarce resource rather than a clock to be punched. This schedule visualizes the required shift. It compresses 8 scattered hours of fragmented, low-level execution into a single, dense 4-hour block of highly focused strategy. You must protect those peak 4 hours for deep governance and creative strategy. Once that window closes, you deploy your AI agents to batch and execute the administrative remnants of your day. The theory of endogenous technological change guarantees that profit incentives will keep driving tech companies to build even more advanced, skill-complementary tools, and these systems will only get faster. The race between education and technology is accelerating. Capturing the cognitive wage premium of the future requires advanced, specialized knowledge, abandoning routine tasks entirely, and the discipline to manage AI rather than compete with it.